Envision a world encased in ice, an era when colossal ice sheets and glaciers reigned supreme, stretching endlessly across the horizon. These titanic glaciers, towering higher than mountains, spanned entire continents, crafting an otherworldly realm of ice and snow. These frozen behemoths sculpted the earth, carving majestic valleys and thrusting up hills, reshaping the planet's visage over millennia. As they receded, they left behind a monumental legacy. Vast lakes brimming with meltwater, pivotal to the evolution of future ecosystems. These glacial lakes, some more expansive than modern seas, were instrumental in molding our planet's history, influencing both geography and climate. A period of profound transformation occurred towards the end of the last ice age, around 13,000 years ago, marking a pivotal moment in Earth's climatic saga. The Earth began to warm and the glaciers commenced their slow retreat, unveiling the land that had been cloaked in ice for millennia. Yet this thawing was not always gradual. There were instances of rapid melting that dramatically altered the landscape. At times it was marked by cataclysmic events, the sudden outburst, floods from these colossal glacial lakes, unleashing vast torrents of water in mere moments. These floods were beyond anything we witness today. They were colossal, ferocious, and capable of reshaping entire regions in a matter of days. Picture a wall of water, hundreds of feet high, surging across the landscape with unstoppable force, obliterating everything in its path. These deluges carved canyons, moved mountains of sediment, and even redirected rivers, leaving an indelible mark on the terrain, but their impact extended far beyond immediate destruction. The floods reshaped ecosystems and influenced the trajectory of human civilizations. The sudden influx of fresh water into the oceans had global repercussions, disrupting ocean currents and altering the climate on a planetary scale. It disrupted ocean currents, shifted weather patterns, and even triggered a period of rapid cooling known as the Younger Dryas, a time of significant climatic upheaval. These events, etched in the geological record, offer us a glimpse into the awe-inspiring power of nature and the interconnectedness of Earth's systems, reminding us of the dynamic and ever-changing nature of our planet. Among the most significant of these glacial lakes was Lake Agassiz. Named after the pioneering naturalist Louis Agassiz, this prehistoric giant once sprawled across vast swaths of North America. To understand its formation, we need to rewind the clock to the peak of the last ice age. As the ice sheets advanced southwards, they acted like giant bulldozers, scraping and scouring the Earth's surface. This process, known as glacial erosion, carved out massive depressions in the landscape. One such depression, formed by the weight of the Laurentide ice sheet, would become the basin of Lake Agassiz. As the climate warmed and the ice sheet began to retreat, it left behind a trail of meltwater. This water, trapped between the retreating glacier and the higher ground to the south, gradually filled the basin. Over time, this massive body of water, fed by glacial meltwater and precipitation, grew to an astonishing size, rivaling the largest freshwater lakes on Earth today. At its peak, Lake Agassiz covered an area larger than all the modern Great Lakes combined. Its shores stretch from present-day Manitoba in Canada to Minnesota and North Dakota in the United States. This immense lake, teeming with life, played a crucial role in shaping the landscape and influencing the climate of North America. For centuries, Lake Agassiz held its immense volume of water contained by natural ice dams formed by the retreating glaciers. But these icy barriers were inherently unstable. As the climate continued to warm, the risk of a catastrophic breach grew ever greater. And then it happened. The ice dam, weakened by rising temperatures and meltwater, gave way. The result was a cataclysmic flood, unlike anything witnessed in human history. Millions of cubic meters of water per second, more than the combined flow of all the rivers in the world, surged across the landscape. This torrent of water, carrying with it icebergs, sediment and debris, carved deep channels into the earth, creating new river valleys and forever altering the drainage patterns of North America. The floodwaters raced southward, eventually reaching the Mississippi River and pouring into the Gulf of Mexico. This sudden influx of fresh water into the ocean had far-reaching consequences. It disrupted salinity levels, affecting marine ecosystems and altering ocean currents. But perhaps the most significant impact of this catastrophic flood was its role in triggering a period of abrupt climate change. Section 4. The ocean's heartbeat falters, the AMOC and the Younger Dryas. The story of our planet's climate is one of intricate connections and delicate balances, where even the smallest change can ripple through the entire system. The Earth's climate is a complex and interconnected system, with ocean currents playing a vital role in regulating global temperatures. These currents act as the planet's arteries, distributing heat and nutrients across vast distances. One such current, the Atlantic Meridional Overturning Circulation, or AMOC, acts like a giant conveyor belt, transporting warm surface water from the tropics towards the poles and colder, denser water from the poles towards the equator. This continuous movement is essential for maintaining the climate equilibrium. This circulation pattern is driven by differences in water density, which are influenced by temperature and salinity. Warm water, being less dense, stays on the surface, while cold, salty water, being denser, sinks to the ocean depths. In the North Atlantic, warm, salty water cools and sinks, drawing in more warm water from the south. This process is a crucial component of the AMOC, ensuring a steady flow of heat and energy across the ocean. This process helps to distribute heat around the globe, moderating temperatures and influencing weather patterns. Without it, our planet's climate would be far more extreme and less hospitable. However, the sudden influx of fresh water from the Lake Agassiz outburst flood disrupted this delicate balance. This massive glacial lake, once held back by ice, released an enormous volume of fresh water into the North Atlantic. The fresh water, being less dense than salt water, reduced the salinity and density of the North Atlantic, weakening the AMOC. This influx of fresh water diluted the ocean's salinity, making it harder for the water to sink and continue the circulation. This weakening of the ocean's conveyor belt had a dramatic impact on global climate. The AMOC's slowdown meant less heat was transported northward, altering weather patterns and climate conditions across the globe. With less heat being transported northward, temperatures in the North Atlantic region plummeted, ushering in a period of rapid cooling known as the Younger Dryas. This event marked a significant and abrupt shift in the Earth's climate. This cold snap, named after an Arctic wildflower that flourished during this time, lasted for over 1,000 years, interrupting the warming trend that had been underway since the last glacial maximum. The Younger Dryas serves as a stark reminder of how interconnected and sensitive our climate system truly is, and how even small changes can lead to dramatic consequences. A tale of two lakes, Agassiz and Missoula. These two ancient lakes, formed during the last ice age, have left an indelible mark on the landscape and climate of North America. The story of Lake Agassiz and its catastrophic outburst flood is not unique. It is a tale echoed in the annals of geological history, where massive bodies of water, held back by ice, eventually broke free with devastating consequences. Across the globe, other glacial lakes formed and drained during the last ice age, leaving their mark on the landscape and influencing the climate. These events were not isolated. They were part of a global pattern of glacial activity that reshaped entire continents. One such lake, Glacial Lake Missoula, rivaled even Lake Agassiz in its size and the scale of its outburst floods. The sheer volume of water held by these lakes was staggering, and when released, it unleashed forces of nature that were both awe-inspiring and terrifying. Located in present-day Montana, Glacial Lake Missoula formed behind an ice dam created by the Cordilleran ice sheet. This natural dam was a colossal barrier of ice, holding back a vast reservoir of meltwater. Like Lake Agassiz, Glacial Lake Missoula repeatedly filled and drained, unleashing cataclysmic floods that carved out the dramatic landscape of the Columbia River Gorge in the Pacific Northwest. Each flood event reshaped the terrain, creating new landforms and altering the course of rivers. These floods, known as the Missoula floods, were among the largest known floods in Earth's history. The scale of these events is almost unimaginable, with water volumes that dwarfed even the largest modern rivers. They scoured out vast channels, transported gigantic boulders hundreds of miles downstream, and deposited distinctive layers of sediment across eastern Washington state, forming the unique landscape we see today. The evidence of these floods is etched into the very bedrock of the region. The Missoula floods, like the Lake Agassiz outburst flood, highlight the immense power of glacial lake outburst floods and their ability to reshape the landscape in a matter of days or even hours. These events were not just geological curiosities, they were transformative forces that redefined entire ecosystems. These events serve as stark reminders of the dynamic nature of our planet and the powerful forces that have shaped it over millennia. The legacy of these ancient lakes and their cataclysmic floods is a testament to the ever-changing face of Earth, a planet in constant motion, sculpted by the relentless forces